So in this particular video, we'll be talking about the locomotion in paramecium. So students, as you all know that paramecium is living in a freshwater kind of a zone, and the paramecium, it is swimming from one place to the other with the help of the cilia. The class of paramecium is ciliata. That means it has got a huge number of cilia over its body. Now these cilia, they are helping in the locomotion of paramecium. Now it is moving in the water medium with the help of these cilia. So if you take an example that you are going in a boat to some place, so you have a spool in your hand, so you are taking it forward and then you are thrusting it backward and your boat moves in the anterior side, towards the anterior side. So that means if you push the water backwards, you will move anteriorly. So the force of water, it will thrust you, it will push you towards the anterior side. So same is the mechanism in paramecium. The water is pushed backwards and the paramecium goes towards the anterior end, towards the anterior side. So let us see how the paramecium locomotes and what is the mechanism of this locomotion in case of paramecium. Now this is a typical diagram of paramecium. So you can very well see that on the upper end it is the anterior end, and at the hind end, at the lower end, you have the posterior end of the paramecium. So whole of the body of the paramecium is having a large number of cilia. So the cilia, they are moving towards the posterior end in a stroke. So that will be taken in the later slides. So here, what I want to tell you is that if the water is pushed towards the posterior end, the paramecium will go towards the anterior end. So this is a very obvious thing. So this is the main course of locomotion in case of paramecium. Now, if we take the second slide into account, so if we take the movement of the single cilium, so the single cilium of the paramecium, it acts like this particular slide. On the very upper diagram, you can very well see that the cilium is moving from right to the left side. So if you see clearly, it is written number 1, then it comes to number 2 position, then number 3, number 4, 5, and 6. So that means the cilium is moving from right, number 1, to the left, number 6. So the movement of cilium is from right to left. So the water, it will be moving again towards the left side. So the cilium will take the water along with it towards the left side. So this particular movement of the cilium, it is called as the effective stroke. Effective stroke means that it will push the water, it will like make the force. So it will apply the force onto the water to make it push towards the left side. So this stroke of the cilium from 1 to 6 is called as effective stroke. It is also called as the power stroke. It is written on the very left side. So in this particular stroke, the water moves from right to left. So as the cilium is going up to number 6 position, now in the second stroke, it comes back to its original position. One thing is to be very clear in this power stroke, the first diagram, that while the cilium is going from 1 to position 6, it is quite stiff, it is hard, it is forcing the water towards the left side. But when it comes back in the second diagram, in the lower diagram, you can see it is starting from position number 7, then it is coming to 8, 9, 10, 11, and 12. So it is coming back now from left to the right side. Now this particular movement is towards the right side. And this stroke of the cilium, the coming back stroke of the cilium, is called as the recovery stroke. So the movement of a single cilium can be divided into 2 strokes. Number 1, it is the effective stroke. Number 2, it is the recovery stroke. So in the recovery stroke, the cilium, it comes back to its original position and the paramecium moves towards the right side. So this is a very, very important thing. So as the board was moving towards the opposite side of the pressure of the force, so in the first diagram, the water is moving towards the left, so the paramecium will go to the right direction. So this is the basic mechanism of the movement of the paramecium. In the next diagram, you can very well see, in the very first diagram on the left side, you have the effective stroke. So cilium is coming from the base position towards the left position, and in this course, the cilium is stiff. And you can see that in the recovery stroke, it is coming back, but it is not stiff. It is very flexible. So as it is flexible, there will be no change in the water position. So as you can very well see that it has been written propulsion of water. So propulsion was on left side, and on the top it is written direction of locomotion. It is of paramecium. So direction of locomotion will be right side. As the water is going to the left, paramecium is going to the right. So I think you are very clear about the movement in a single cilium. So there are 2 strokes, effective or power stroke. Second is the recovery stroke. Okay, students, so after single cilium movement, now we have another concept which is shown in the lower diagram. Now, paramecium has got hundreds of cilia. So all these cilia, they are moving together in groups. So as you can see here, a number of cilia are shown and they are moving in groups. Suppose you have a crop field and we have wheat in that particular field. So when the air blows, whole of the plants of the wheat will go to left side, then they will be coming back straight, and then again they will be going to the left side, then they will be coming back again to the normal position. So all the cilia over the paramecium, they are moving in a rhythm. They are moving together. So that particular motion of all the cilia of paramecium is called as the metachronal wave. It is also called as metachronal rhythm. It is also called as synchronous rhythm. That means all the cilia, they are moving continuously. If they are moving on the left side, all the cilia, they are moving towards the left. And if they are in the recovery stroke, all the cilia, they are in the recovery stroke. So they can synchronize with each other. So there is not a kind of situation where one cilium is moving towards the left, the second cilium is moving towards the right. So this is not the situation. So in case of paramecium, all the cilia, they are moving synchronously in groups. So that is called as the metachronal rhythm or metachronal wave. Now students, if I go with this diagram, this is a very, very important diagram. So up till now, we have discussed that paramecium, it strokes back the water towards the posterior end. The water moves backwards and the paramecium moves towards the anterior side, up to the upper side. But now I am discussing a second aspect of the movement of paramecium. And this aspect is that the paramecium is not moving in a straight, direct path. So it is not moving in a straight line. Actually, the movement or the locomotion is in paramecium, it is anti-clockwise spiral movement. So as you can well see here in this diagram, it is shown that it is moving anti-clockwise. That means towards the left side. So if you take your hand against your face, and now you can move it in anti-clockwise direction. So this is the case in the paramecium. So it is moving anti-clockwise and spirally. That means it again moves in a motion of like a spring. In the next diagram, you can very well see the spiral movement. So here, if we consider the position 1, it is on the right side of the line. So it moves anti-clockwise as well as spiral. So in number 2, as you can see, it is on the right side of the line. So and at number 3, it comes over the line. And at number 4, now it is on the left side of the line. So at number 5, it is again coming back to the original position as it was in number 1. So it is below the line. Now here we can very well see that first of all it is moving towards the anterior side. That means towards the right side. So here we have written direction of movement. So this is the direction of the movement. So that means it is moving from left to the right side. Why it is the right side? Because this is the anterior end. So anterior end is the blunt end and the posterior end is the sharp end. So it is going towards the anterior end. So that means towards the right side. So it is moving towards the right, but anti-clockwise spiral movement is shown. Now students, why it doesn't move in a straight line? There are basically 2 reasons behind this anti-clockwise directional movement. Now if we consider the first case, it is because of the cilia. Now, the cilia, the reason behind the spiral movement is that the cilia, they are not exactly moving from anterior to posterior side. They are moving at an angle. So they are moving at near about 15 to 20 degree angle at one side. So that's why they tend to move the paramecium spirally or anti-clockwise. So this is the first reason that the cilia, they are not moving exactly towards the posterior end. So they are moving at an angle. So that's why the paramecium, it moves anti-clockwise spirally. Now the second reason for this movement is the cilia of the endural membrane. These cilia, when they move, they make their own water current into the oral groove. So endural membrane cilia, they are the cilia which are present on the oral groove, and they are functioning for feeding purposes. So when they move, they make a water current of their own, and that water current, it counterfacts or it counteracts the straight motion of the paramecium. So that's how the paramecium moves spirally or anti-clockwise. So students, these are the two basic reasons that why the paramecium is moving anti-clockwise, spiral. So I think you are very much clear about the locomotion in paramecium. So overall, in this particular question, you have to make two diagrams. Number one, that is the diagram of the cilia, which we had discussed earlier. This is the diagram. So you can give the effective stroke and the recovery stroke, the propulsion of the water, the direction of the locomotion of the paramecium. Then you have to give something about the metachronal wave. Then you have to make this particular diagram. This is the diagram that you have to show here, that it is anti-clockwise spiral movement. So with these two diagrams, you can explain its movement. So that was all about the locomotion in paramecium.